This is Lewis Moore. He's our the ME technician. He runs all the safety training, and he runs the engineering shops.
Alrighty. But you probably already have heard this today is that engineering is design and manufacture, right? So our facilities here support the manufacturing side of the student projects, and starting from when they're sophomores taking 213 to senior design for 482, which we're in right now, right? Okay.
Yeah.
So this is so what we have here and where you're at right now is our 3D printing lab. This is very different than your PLA machines that you have at home. These are industrial standard printers. They do FDM. The first ones we have over here are Stratus FDM. Right? So what happens is students will bring in a design. They'll submit those designs for printing, and then we can manufacture actual parts. It's not like the stuff you would get off of the smaller
lab tour.
So when we have
Yeah, so these are the machines that we have. The parts that do come off of the Stratus right here, let me show you. This one failed to start, so we'll have to figure out that one. Okay, so this one will start in printing, and the parts that it is printing are for a civil engineering lab, right? This is part of the equipment they have for testing the flotation of methane gas. And then we print those here in this machine. You can see a model of it up here, right? And then that actually does the printing. This one's printing another one. I can show you how these are done. So we have a website that the students have access to. Describes the training we have to do. They have to go to gain access, some of our safety cultures, and then there's the 3D printing page. And students will submit their design that they worked on for last semester to us, and we'll put it through the form and generate a solid model. We'll lay it out. We'll set the specifications that the students requested, right? And then we load it into the machines and print. The nice thing is that we have two machines. The first machine we got was the smaller one, the Stratus. That's this one, F170, and it prints in ABS, ASA, and PLA. The success that we've had with these, because this one runs 24/7 during the end of the semester. We purchased a new machine, which helped with the COVID response as well. But this one prints in additional materials of rubber and Darin, which is similar to Delrin, which is like a material you can use for bearing in wet environments. So, we continue to increase our capacities with 3D printing because students will be able to do their design, submit for manufacture, and we don't have to do the training for manufacture. And these machines produce usable, functional parts, right? What's also nice is we continue to upgrade, right? So this is our Mark Forge Mark II. It prints with nylon, a carbon-filled. It prints with a carbon-filled nylon. It's called Onyx. And it also has the capacity to insert a carbon fiber filament within that print to make it even stronger than just aluminum. They say that Onyx, the Onyx filament is as strong as aluminum, and then you can add carbon fiber to even make it stronger. And you can add that carbon fiber depending on your part, how you want the filament to lay out. Right. So what we've been practicing, so the whole shop's been going through a renovation. And the last thing we've added is this metal 3D printer. So in partnerships with Pearl Harbor, who's assisted us in acquiring the machine, we're now able to print 3D metal parts.
Mm-hmm.
It uses a wax filled, this one is stainless filled wax filament with ceramic. And produces a part. So this is called the raft. Between the raft is a layer of ceramic, and then this is the actual part. The advantage of using this machine is that we're able to take the solid model that the student develops, put it through the programming of the software for this printer, and it sets the dimensional tolerances inside the print. Because what happens is parts will shrink when they go through the oven. So the computer calculates all that. So the nice thing is you're going to get what you give us, right? And the software and the printing process has all been figured out.
Oh, okay.
So
Oh, that's really good.
the number on this is like 250,000.
Oh my god. It's from Pearl Harbor, so it's okay.
They were assistants. So
Yeah.
we assist. There are students, seniors that are now right now as apprentices at Pearl Harbor, right? As interns, and this is part of that program.
Yeah.
Cool. Any questions?
You guys have any questions so far?
Feel free.
There's a chat. Yeah, feel free. Chat.
Shout it out too.
Okay. Yeah, you guys can talk too.
Student skills.
Yeah. I've never done it on my iPad, so. If you guys have any questions at any time, then just.
We actually have
how
a
much?
question that came in from Jason Kanemoto. How much does it cost to use the 3D printers for students?
Students is the fee is covered by their fee that they pay every semester for students.
Yeah.
So all the materials that are here available for students. Students have already paid for that.
Yeah.
That's great. So no additional charge per use. Yeah.
For class projects, exactly.
Yeah.
Yeah, great. And we are one of the few facilities in Hawaii that has this type of metal 3D printer, correct?
We're the only facility in Hawaii that has a metal 3D printer.
The only. Very cool.
Yeah, I think so too.
Yeah. Really good.
And as we talked about earlier in the day today with our industry partnerships, again, this is just an example. And in this case, it's the partnership with Pearl Harbor, the Naval Shipyard, right? Just one of those amazing opportunities for us to collaborate with industry, and one of the benefits of being in Hawaii and having access to, you know, entities like Pearl Harbor that can make this possible and develop this partnership that's really a win-win for both us and for them.
Yeah. They make a comment that they would not have been able to do it as quickly as we were able to do it because of the nature of how things are done at Pearl Harbor. So,
yeah.
So it's our advantage, yes. And we've worked out all the bugs for them. That's how it works. And then they're asking us to, what's it called? A shakedown cruise. So they will submit prints, and other professors can submit prints and produce white papers on the research, and then student projects that have been started by Pearl Harbor to do some of the things they've had questions at. So yeah, we're moving ahead already. We've started the print.
Excellent. And for those who might have missed, what is the price tag again for a lovely piece of equipment like this?
250,000.
250,000.
Wow.
Thank you, Pearl Harbor.
Thank you very much.
Yeah.
There's more. Shall we take a walk?
Yeah.
So,
Yeah, let's continue on. Thanks, Louis.
so 3D printing is the easiest for us to manufacture and for the students. You know, if the part can be printed, that's the quickest way and cheapest way to get it done. So you can see the walls are painted. They're all nice, fresh white. We've installed LED lights. This space, hopefully by September, will be available to students in a program process, so we can initiate some real manufacturing training right away. I'm hoping that some of the seniors might gain some access towards the end of the semester for their parts, but this is what we've done. This hasn't been set up like this before. This is new to our department. The lathes, the mills, all set up in a way that the students can gain access. This is their machinery. This is
moved from 140.
Yeah, this is the shop that used to be in 348.
340. Oh.
And then it's moved down. It was moved down here to organization of spaces. Mm-hmm. But because we had to repaint the walls, mm-hmm. clean the space, this is an opportunity. We took the opportunity to rearrange the whole space.
Mm-hmm. Oh yeah.
Yeah. And it makes it more comfortable to do training and for students to gain access. Mm-hmm. There's the oven for the 3D printer, for the metal 3D printer. Mm-hmm. You can see how it's really an investment. The space that's required for such a piece of equipment. So yeah, we were very lucky that mm-hmm. You see how much gas it takes
to run that. Yeah. Is that just for the oven?
Yeah, that's for the oven. The silver unit there in the corner underneath the freezer.
Mm-hmm. Oh, okay.
Yeah. Yeah, this will be. We have the training project, like I showed you on the website. Yeah. If I didn't show you the YouTube channel, I can do that. Mm-hmm. But we have part that they make to gain certification on the red level side, and the other shop that I'll show you next. And then there's training on this equipment as well. Mm-hmm. Yeah, neat, huh?
Yeah.
Kind of the bird's eye view.
Really good.
Yeah, you're in the crow's nest. Mm-hmm.
And I was here before, and it was really very different, yeah.
So it's nice when you have the opportunity to rearrange the space. Mm-hmm. So you've got the red level training at 148?
Yeah. Oh, no, for 213 only.
Okay. Oh, let's walk through it.
Yeah. A long time ago. Oh, I'm not certified anymore. I should say that.
Oh, yeah. Did you run a drill press?
Yeah. Oh, I'm still certified? Cool.
Yeah, it's a red level training.
Oh, okay. Thank you. This is how Mānoa looks like. If you see on our backgrounds before. This is the front of the school. Or when you come up from Dole Street, our lawn.
Yeah, we have a little golden, what is it called?
I know, right? This is where Engineering Ohana, the residential learning program, that's the building right there. This is where they're housed, right across. In Johnson Hall, A. Yeah. Right there.
81 out of that room.
Mm-hmm. Really? Oh, you remember?
Yeah.
Still there.
I was in that room.
Oh.
Are you passing our Aloha Net plaque? Or oh no, you already passed, huh?
Oh, it's over there.
The Aloha Net?
The plaque.
Oh.
Yeah.
Yeah. Oh, yeah. This is the world of engineering.
So this is something we're pretty proud of. We actually, in the fall, we had a dedication ceremony with Governor Ige and some special guests to commemorate Aloha Net, which was the first wireless network in the world that was developed right here at the College of Engineering and is the backbone to modern day wireless communications and to the development of the Ethernet and other subsequent technologies. We're actually having a 50th anniversary ceremony or celebration, I should say, with a mini symposium in June. And we are just one of 3 IEEE milestones here in Hawaii, which is the Electrical Engineers Association internationally. So very cool. That's our plaque.
Yeah. 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 It's getting busy.
bear with us as we connect in and out with our students moving. They are heading to the second part of this facility, room 180, or 140 rather.
140.
This is 140A.
Yeah, 140A.
We have a new sign.
Yeah. Oh, yeah.
Oh, nice.
So I already have the space. Take a look.
Okay. Thank you. Yeah.
So the very first part of fabrication is your hand skills, your mechanicals and that. It's the drill, the chop saw, the drop saw, band saws. We also have the advantage of having a couple more CNC machines here. That's a multicam. Come this way. The Shapeco. And then we also have another CNC machine going together called the X-Car. Automation of fabrication is kind of where we're at right now. It makes things happen faster. You get a quality product. You don't need to know so much manufacturing skills. And the machine does all the numbers and stuff. Hi. But you were talking about your red level that you got, right? So you at that time, did you use the drill press?
Yeah.
And you used the saw, right? You only have to do that once. We get you through there. We're hoping that once you've experienced and gained the knowledge of using that equipment, you volunteer for space in the shop. The advantage of volunteering in the shop and helping others, like other come in and do the red level training or assist in their school projects, is you get to work on your personal stuff. That's how that happens. And then from here, you would go to learning how to use the mill and the lathe and doing welding. I take it a welding space, but right now that's really messed up, not safe to walk through right now. But this is the space that, again, we use for students. We've been challenged to make this COVID accessible. So that's what we're doing next week. Yellow lines on the floor for access, 6 foot, 12-foot circles around the space. Of course, you can see some of the machinery has to be rearranged to make that possible, but that's our challenge for this semester. That's for your 42.
Yeah.
Okay. Any questions?
Any questions?
Feel free to type in any questions you might have and we can read them out.
That was a student project.
Oh, yeah.
Really?
This here was a student project. They were making musubi stamp or stamps for New Year's. I think mochi stamps.
Can you raise the camera just a little bit, Chris? Okay.
That was somebody was designing a stamp for mochi, for New Year's.
That's cool.
That's cool. So that's what it was. But that was a student. He had been trained in the space and knew how to access the machinery. This is a Shapeco.
I have used this before
You've
for
used that before.
341.
Okay, awesome. Yeah, Dr. Miller's class.
No, I did Dr. Johnson.
Dr. Johnson.
Oh, okay, a question. What is the largest object that the Metal 3D printer can create?
Okay, right now the diameter is, right now it's 5 inches by 12 inches because it's a center one. There is discussion and rumors that there may come a larger oven available, which is a Cinder 2. And the Cinder 2 can print the volume of the metal.
Oh, okay.
All of that stuff's available online.
Online.
Nice. And what's nice is the metal printer doesn't just print stainless, it prints stainless, copper, tool steels, Inconel. There is a big research they're doing right now to see if they can print titanium.
Titanium. Oh, okay, that'll be good.
Titanium would really push that piece of equipment over the top.
Definitely.
Yeah, that's the current research.
Any more questions? Well, do you have anything else to say?
I'm good.
Okay. I'll just, if we wait for questions, then give a tour.
Yeah, that's hazmat. That's going out the door.
Mhm.
I get to do that a lot.
Mhm. Throw it out.
I'm not only the the instructor, I also get to take care of the safety.
Safety. Oh, yeah.
So yeah, this is probably 3 years old.
3 years old. Oh.
It's full.
Mhm.
I found it at the bottom of the floor.
Oh, it's kind of dangerous. Mhm. Formula. Oh, just kidding.
That's so part of the process of the metal 3D printer, which is interesting, is this piece of equipment here. It's called a wash tank. It uses a special degreaser, which is, evaporates at a low temperature. So it requires a special type of bath. Inside this bath, there's this is a refrigeration ring, right? So the gas evaporates at a low temperature. And as it rises and evaporating, it's stopped by this wall of cold air and it falls back into the tank. So because we had a power test last week, I had to drain and secure the machine.
Oh.
Yeah, if a blackout happens, it all disappears. Each bottle is $800.
Oh my God! Wow.
Yeah, so we do monitor that stuff.
High priority.